Right, good morning class. So today we're looking at geometry. Favorite? So we're on page 40. Right. So we are told that ABCD is a square. People, if this is a square, what do we know? Four sides are equal, yes? All sides are equal. Vertex angles are 90 degrees, yes? Two pairs of opposite sides are equal. Parallel, sorry. Diagonals bisect each other. Diagonals are equal to each other. Diagonals bisect the vertex angles. And that one is making bad angles are perfect. Right. Yes. No. So we're back at it. We just need to wait till the what's the name goes on? Please, when you go to other classes, tell them to put off the heaters. Yes. Right. So we are told that ABCD is a square, and then we are told that AEB is 54 degrees. AEB, that's 54 degrees, or E1. They ask you to calculate F1. F1. Anybody? How do we calculate F1? You had a good weekend, Jemima? I can see you. You're smiling today. I'm not going to ask you what you did the weekend, okay? People, F1. Now I'm going to calculate F1. Yes? Nice! She says A1 is 45 degrees. Why? It's 45. Now all of these are 45. Is that 45? No, because that's not the diagonal. Can you see that, people? So A1 is 45, why? Because the diagonal bisect the vertex angle. But also the vertex angle is 90 degrees. You must add that. It's not enough just to say it's bisecting the vertex angle. Okay, nice, well done. Now what? How do we calculate F1? Summing triangles, not so. So angle F1 is equal to 180 minus 45 minus 54. Why? Sum of triangles. And this triangle, AFE. Which gives you an answer of? Go to the calculator. First time you see the black one? Black is beautiful. 81. Right, you guys got it? Don't lose it. Alright, any issues there? Carry on with our lives. In. Come on, see? Right, we are told that ABCD is a rectangle. People think 6 things should come to mind. 6 to 5. How many properties come to mind? 5. The ABCD is a rectangle. So what is the first one? Opposite sides are parallel. Opposite sides are equal. All vertex angles are 90 degrees. Diagonals are equal in length. Diagonals bisect each other equally. Huh? What? The vertex angles are the same? No. The middle? 90? No. There's only 3 shapes where that is the case. What are the 3 shapes? Square, kite, rhombus. Hoe kyk? I'm still busy with the rectangle story. Don't jump the gun. Or you will see reading the rhombus one. And DECF. DECF is a rhombus. 16 centimeters. 6 or 5? 6. Right, what are the 6? All sides are equal. Next. 2 pairs of opposite sides. Parallel. 2 pairs of opposite angles are equal. Diagonals bisect each other. The diagonals bisect the vertex angles. Diagonals are perpendicular. 6, yes. Alright, this is how you must know it. Okay. Then we are told that DEC is 60 degrees. DEC 60. So what does that mean? E1 is 30. So is E2. And so on and so on. Okay. So let's go with number 1. Okay. Number 1 says E1. So we said E1 is equal to 30, which is equal to E2. E1 is equal to E2, which is equal to 30 degrees. Why? Diagonals bisect the vertex angle. So it's 30 here, 30 here. Huh, they didn't ask E2. But okay, I got it. That's why they asked E1. Eh? People, F1. F1. This one here. Sorry? Opposite angles in a rhombus are equal, yes. And then diagonals bisect each other. You all agree with that? There's another way I could have done it. Yeah? Lines are parallel, yes? Beautiful. Right. So which one you want to go with? The first one. You go with the first one. So we are saying firstly that, let me first take this out here. We are going to say that DFC is equal to 60 degrees. Why? 2 pairs of opposite angles equal in rhombus. Okay, so there's 60. Then F1 is equal to F2, which is equal to 30. Why? Because the diagonal bisect the vertex angle. Okay. Right, so we got F1. B2. B2. Ha, B2. Angle B2 is the same as which angle? D1. How can you calculate D1? Sorry? So alternative? F1. Nice, beautiful. You will see that. Pumla? You're good. Alright, so when we start, we need to end up at B2. Alright. So we need D1 first. But we need to know that that line is parallel to that line. That's it, going to be an issue. These lines are parallel. We know those lines are parallel. Yes? Yeah, it's 90. We know that, yes. So how's that going to help us? Okay, could I say this is 45, 45? No, why not? Why can I not say those two angles are 45? When would it be 45, you would say? A square, yes. Then not given a square at this point. Yes?
So could you say G1 is equal to 19, say it's corresponding with
G1, say again?
G1 is equal to 19.
G1 is 90. Why is G1 90? Sorry? Diagonals are perpendicular in a kite. Nice. In a rhombus. Yes?
And D1 plus D2 is equal to 90.
Yes?
And it's corresponding.
Sorry?
And it's stated is corresponding.
Sorry?
Stated is corresponding.
Corresponding. What is corresponding?
D1 plus D2 is equal to G1.
D1. Oh, you're saying co-interior. Corresponding. It's co-interior. So now those lines are parallel. Is that what you're going to do? Nice. Well done. Since somebody said G1 is 90, it became actually easier. Does anybody see it now? If G1 is 90, what can be determined now? D2, yes. We got D2, what can be determined now? D1, so that's 90. Then alternate. Can you see that, people? And that's the route I will be taking. Beautiful, son. I like it. Right, let's go. G1 is equal to 90. Why is it 90? Because diagonals perpendicular in rhombus. D2 is equal to 180 minus 30 minus 90, which is 60. Why? Summing triangles. And it's triangle DFG. Okay. Any confusion there? Now we're saying that D1 plus D2 is 90. Why is D1 plus D2 90? So ADC is equal to 90. Vertex angles equals 90 in rectangle. Which makes D1 90 minus 60, which is 30 degrees. Now, we can go with alternate at this stage. Now, why not? The lines are not given as parallel, but we know that AD is parallel to BC. Why? Two pairs of opposite sides parallel in a rectangle. So therefore, finally, P2 is equal to 30 degrees. Why? Alternate. Can you see that ZD? Maybe 30. So alternate angles with AD being parallel to BC. Was there a quicker way? Sure, there could have been a quicker way. Well, I'm hoping it's a quicker way. Right, B1. Yes.
Can I ask if we, so you say isolated AD is parallel to BC, can we put that in the reason word factor of D1 plus 90, plus 60 equals 90 degrees? Can you put that?
So instead of writing this, you want to put that there. Yes. You don't have to write it. Nice question. Anybody else? Yes? Not the one that we just spoke about before. A different method. Okay, what did you do? Okay, good. Sorry?
With all after you said that DC is parallel to FE.
BC is parallel to BC. BC is parallel to?
FE.
How do you have that?
I didn't complete it the other way.
You use co-interior. Okay. So use co-interior which way? This way.
No, the G, with the C.
This here.
Yeah.
Okay. Let me just follow what you're saying. Oops. Okay, what do you say? So you said this was 90. Okay.
Parallel corresponding with B to F.
Sorry?
B one F corresponding.
B?
F.
What's the angle?
A, B, C.
A, B, C. Yes, it's also 90. Yes?
Now I got F, B, C,
If B, C is?
and F1 equal.
Okay, so you're going corresponding that way. This is after you prove that that was parallel to this. Okay, nice. That's also another way. I'm sure there's another way. But we don't want the video to be too long. Okay. Alright, anybody else? Any confusion here? No? So they asked you for B1. Are you going to get B1? We know that is 90 degrees, not so? So we're going to say that B1 is equal to 90 minus 30, which is 60 degrees. Why? So the vertex angles equal 90 in rectangle. Okay, let's look at number 2. Number 2. Calculate the length of AC. So AC is this length here. If EC is 4, right? If EC is 4, which other angle? Wait, just see with AC. AC is this length here. Okay. People, if EC is 4, what other length do we know? Sorry? Sorry? FC. How do you know FC? It's the same. Nice. Why is it the same? All sides are equal in a rhombus. So FC is equal to 4 centimeters. All sides equal in a rhombus. Okay. Then what? FC is equal to AF, which is equal to 4. Why is that the case? Because diagonals bisect each other equally, or you can just say in this case each other, in a rectangle. So therefore, AC works out to be, what's the length of AC? Let's see. Do I need a reason there? No, because I have not used any Euclidean reasoning here, or rule. I don't need a reasoning. Beautiful. Yeah? Okay. Next, we're still on page 14. 15. Right, let's go to 15. Oh. Page 15. Oh. People, we are told that ACDE is a kite. A, C, D is a K. 5 things comes to mind. What are the 5? 2 pairs of adjacent sides equal. Sorry? 1 pair of opposite angles are equal. One diagonal bisect the other. There's no diagonals here. One diagonal bisect the vertex angle. That one is not here. Sorry? Diagonals are perpendicular. Those are the 5. No? Which is also not evident here. Okay? So those are the rules we're going to, those are the properties of the rectangle we're going to use. Okay? So the others is not going to be evident here because there is no diagonal. Unless they say sketch, you draw in the diagonal and then that comes into play. People, then we are told that ABGF. ABGF is a kite, is a square. 17 come to mind. What are the 7 properties? Both sides are equal. Which making you now you see before we go any further, you see those lengths are equal. Which means to say that C1 is equal to C1. So isosceles triangle. You see that? Another one, 2 pairs of opposite sides, parallel. Number 3, vertex angles are 90 degrees. Number 4, diagonals are equal in there. Number 5, diagonals bisect each other equally. So that lengths are all equal. Number 6, diagonals bisect the vertex angles. Number 7, diagonals are perpendicular to each other. Okay. People, it's going to be beneficial to know the properties of power. Okay. Then we are told that AB is equal to BC. That lengths are equal. Then we are told that C1 plus C2 is 90 degrees. Up 110. 100, sorry. 10 under 10 over. It's 100 degrees. Does that mean to say C1 is equal to C2? No. That doesn't mean that. Then we are told that AC is 14. AC, people, the whole length is 14. So what can we say? AB is 7 and BC is also 7. Can you see that, people? Calculate with the reason the length of AE. Calculate with the reason the length of AE. People, what's it? Why are they in some task like this? What's the length of AE? 14 cm. Why? 2 pairs of adjacent sides equal in right. Right, so there's 14. Number 2. The length of GF. GF. This length is the same as BAB. Not so. Why is it the same? Both sides are equal in a square. But what is AB? 7. Why is AB 7? Why is AB 7? Given, yes? What have you given? AB is equal to BC. You don't have to write given, you can just say AB is equal to BC. Okay. Now if G is equal to BG, which is equal to AF, which is equal to 7. Why? All sides equal in square. Did I have to say all of that there? No. I could have just said what I want. Okay? But if I need to use it again, then I can just say. Okay, this is also 7. Okay, I don't have to say because I have to say. Okay, any confusion, people? Number 3. Number 3, we are told the size of angle C1 and C2. As we see, people, that is not the same. But we know that C1 is equal to C1. C1 is equal to G1. Why? Because angles opposite equal sides. So that the angle is equal to that angle. Now what? What's the size of B2? 90 is. B2 is 90 y. All vertex angles equal in square. All the vertex angles are equal in a square. So B1 is what? 90. Why? Straight line. Or I would have gone exterior angles equal to sum of two interior opposite.
My apologies for the interruption.
You see that, people?
Risha Ahmed and Amani Shabadi, can you please report
So
to the
C1
office with your bags?
Plus G1 is equal to B2. Why is C1 plus G1 equal to B2? Exterior angle of triangle is equal to the sum of the two interior opposites. But now I don't need to say all this Mickey Mouse here. I just say double C1 is equal to 90 degrees. Why? Exterior angle of cyclic quad. Sorry, exterior angle of triangle. And it's triangle BGC. Cyclic quad you're doing grade 11. Getting ahead of myself here. So what do? I divide it by 2. So C1 is equal to 45. That is 45. No? That's also 45. Why can I write it in? Because I already said C1 is equal to G1. Any confusion? Okay. And C2? You want C2 as well? So C2 is equal to 100 minus 45. Why? Why is that the case? It is given that ACD equals 100 degrees. Okay. People, all of these things count for marks. Okay, but if it's not on the diagram, you must state it. Otherwise, you're going to lose out. Okay. We'll put 55 here. Let's carry on with our lives. Number 4. The value of x. Where's your x? X is far from our lives, no? Right, now we're going to solve for x. Sum of triangles. Nice. Are you opposite to go along with it? The balance is sum of triangles. Who's it? Well done. Those lengths are equal, sum of triangles. Because I have C2, E2 is the same, of angles opposite equal sides. The route I was going to take was, I would have first worked out this, which is 90. Why? Vertex angles in a square. Then this is 100. Why? One pair of opposite angles are equal in a kite. Then I would have gone sum in quads, give you 360. Okay. That also give me a trip. So we're saying firstly that CD is equal to ED. Why? Why is that equal? Because two pairs of adjacent sides equal in kite. Right. Then E2 is equal to 55 degrees. E2 is 55 degrees. Why? angles opposite equal sides. Okay? And then x is equal to 180 minus 2 times 55. Why? Sum in triangle. In this triangle, DEC. So it's 55 1/10, give you an angle of 70 degrees. Beautiful. Okay. You can't help but love the sums, ne? This is the last one on this page. One more. Right, P. You are told that A, B, C, D is a parallelogram. If A, B, C, D is a parallelogram, what do we know? 4 things comes to mind, 4 properties. What are the 4 properties? Opposite sides are parallel. Opposite angles are equal. So that is going to be 30 and 30. Can you see that already? So that's going to be 60. And those angles are equal. Opposite sides are equal. Whoops, not that one. Oh, I got 3 and these 3. And last one, diagonals bisect each other, which won't be the case here because there is no diagonals. Okay. And right, then we are told that AE bisect. Bad, yes. So what happens? Bisect, so A21 is equal to A2. Angle C is 60. Nice. As we indicated, that was going to be 60 as well. Then we are told that AE is perpendicular to EB, sorry. There's 90 degrees there. Then we are told that B2 is 2x plus 20. And angle D2 is going to be 3x plus 30. Calculate the size of E3. Calculate the size of E3. Here's E3. So for E3, I need to know the size of E2. Not so. Then I can go with revolution. So I already got that 90 there. However, for E2, I need to know that those two angles are equal, not so. And earlier on, I already indicated that that is 60 and then that's going to be 30. So that will be 30 and then I can go sum in triangles to get E2. You will see that. So let's go with that. Yeah, I'm hungry now. Yes?
That's a revolution, and what's a reflex angle?
Reflex. This is a reflex. A reflex angle is an angle that is greater than 180 but less than 360. Understand? Whilst a revolution is an angle that goes all the way 360 degrees. Okay? Alright, so let's go. So we're firstly saying that DAB is equal to 60 degrees. Why? 2 pairs of opposite angles equal in parallelogram. Then A1 is equal to A2 is equal to 30. Come people. Why? So it's given that AE bisect DAB, angle DAB. So put 13 here, 13. Then we say that D1 is equal to 30 degrees. Why? Angles opposite equal sides. Now we can go with sum of triangles, which now gives me E2 is equal to 180 minus 30 minus 30. Sum of triangles, and this triangle DAE, which gives me 60. 180 minus 60 is 120. Okay. Have I answered the question? No. Therefore, 3 is equal to 120. Or first the E3 plus 120 plus 90 equals 360. So I'm going to say 360 minus 120 minus 90. Give me an angle of 270 is to 150. Let's check then. 360 minus 120 minus 90. 150. Why is it 150? Because it's a revolution or angles around that point. Okay? Take a triangle out here. People, all this information that I just calculated is on the diagram. As you know, I need the space on the diagram. I need the space to write, so take it off. I would like to keep the diagram in focus. Okay. Right, so what was E3? 150. People, in number 2, the question says, calculate the value of x. Now you see here's the x's, or you see all the x's bond together. No? Alright. And what type of shape is that? Quadrilateral. What do we know about the angles of a quadrilateral? Adds up to 360. So in other words, 3x plus 30 plus 150 plus 2x plus 20 plus 60 equals 360. Why? Angles in a quad equals 360. Or sum of angles in a quad, whatever. You don't have to say it's equals 360. 2x plus 2x plus 3x is 5x is equal to 360 minus 360 minus 30 minus 150 minus 20 minus 60 gives us 100. So divide by 5, so x is 20. Right. This is not part of your syllabus, but I'll show you anyway how it works. Number 3. It says prove that D2 is 90. No, that's a fair question. Absolutely fair. This is straight substitution. Not so? So you say D2 is equal to 3 times 20 plus 30, which is equal to 60 plus 30 is 90. There's a job done. People, you guys understand? Any confusion? No. So that brings us to the end of this lesson, or this video, dealing with pages 14. Okay.